Continuing on, we know that this element is lithium, so your element symbol is going to be Li. And we know the atomic number for lithium is 3. You have to look at your periodic table for that. The mass number is given right here. So you might remember that that number is the mass number. It's going to be 7. Number of protons would be 3, because that equals the atomic number. So you need to remember that these two are the same. Since there's no charge, electrons and protons are equal. So that's 3 also. And we know that protons plus neutrons equals mass. You've already written that on your cheat sheet, right? So this is going to be 4, because 3 plus 3 here plus this has to equal 7. For magnesium, the atomic number is 12. Look at your periodic table. Mg stands for magnesium. We know that there are 13 neutrons. Since protons plus neutrons equals mass, the mass has to be 25. It'd be 12 plus 13. Total number of protons is 12. I already said that, but I said atomic number because they're the same thing. And then over here, you write the name. It's tedious to write this out, so I'm going to do that. So that's magnesium and then hyphen 25, because you need to write the mass. There you go. Magnesium 25. That's a 25, obviously. All right, so now moving on. Arsenic, you're going to put the electrons in. So arsenic has 33 electrons. You look at the periodic table, the atomic number is 33. Since there's no charge in this situation, we're just doing the atom. Remember, it'll say -3 next to the arsenic, but that's the charge it would be if it had a charge. So you have to put the arrows in, up and down, like that. You're going to go all the way up. I'm going to skip that, but when you do it, you'll fill them all in until you get to this, and you'll have 3 single arrows in the 4p. So the full electron configuration I'm going to say instead of write. So I'll write the first part of it as 1s and then a 2. So then you have 2s2, then 2p6, 3s2, 3p6, 4s2. What comes after 4s? 3d, 10. There'll be 10 electrons here. And then 4p will have 3. So it'll end in, the last couple things will be 4s2, and 3d10, and then 4p, and then 4p3. All right, now, the outer shell is the highest energy level. So you can see right here, the highest energy level will start above this line. It'll be 4s and 4p. 3D is not the outer shell because the 3 is not as big as 4. So the outer shell configuration would be 4s. Well, I'm just going to circle it over here. It'd be this and this. Those are the 4. So 4s2, 4p3. And well, maybe I can write it. The noble gas configuration, when you're doing the noble gas configuration on the periodic table, you go up one row, then go to the far right. So in the case of arsenic, the element that's up one row and at the far right end is going to be argon. Argon has 18 electrons. So argon, just writing the symbol argon in brackets like this, that covers 18 electrons. Then you write what's left over. So in this case, it'd be argon, and then these things here would be written right after argon. So the configuration will be AR in brackets, and then 4s2, 3d10, 4p3. Now we've got a chart which has charges. And remember, I put all this stuff. Atomic number equals protons, always. If the atom is neutral, the electrons equal the protons. If there's a positive charge, the atom's lost electrons, so the charge becomes positive. If there's a negative charge, the atom has gained electrons, so the charge is negative. And then protons plus neutrons equals mass. All right, so atomic number 7, that tells us the mass is 15 over there in the hyphen notation, so that's 15. The number of protons would be 7. because the atomic number equals protons. Number of electrons here, there is a charge. It's negative. So have you lost or gained electrons? So you've gained. So if you had 7 normally and you gained 3 more, you'd have 10. Protons plus neutrons equals mass, so 7 plus something equals 15. So the something has to be 8. On this one, the silicon is the element symbol, Si. The atomic number of silicon, we already know without even looking at the table because we can see the chart tells us that there are 14 protons. So these two guys are the same. The mass number would be the protons plus the neutrons, so that'd be 29. And we already know the mass number because it tells us right here. And then the electrons, since there's a positive charge, have you lost or gained electrons? So you've lost. So you're going to end up with 10 electrons. So it has the same number of electrons as nitrogen did. Our periodic table section. This you got to know that atoms get bigger as you go down. So if you're going down, they get bigger. And they get smaller as you go across. So you start big on the left side, make it a little bigger. You get the idea that they get smaller as you go in that direction on the periodic table. So as you go right to get smaller, as you go down to get bigger. So here's chlorine. Chlorine would be like right over here. So fluorine is above chlorine, so the answer there would be B. Bromine is below chlorine on the periodic table. You need to take time to look at these things. Make sure you know what I'm talking about. So that would be D. The higher ionization energy would be the smaller atom. So that'd be on this picture, it'd be this one up here. So which one of these is the smallest? That would be B. Okay, notice that there's a negative sign right there. So if chlorine has a negative ion, the symbol looks like this, I kind of covered it up. If it has a negative charge, that means it's gained an electron. So if you gain an electron, you get bigger or smaller. So that'd be circle D. The furthest right in the series on the periodic table, remember they get smaller as you go to the right, so that would be B. Oops. Closest to the bottom would be the biggest one. Right, they get bigger as you go down. You might want to put this picture on your cheat sheet. Okay, closest to the bottom, that'd be D. Most likely to lose an electron, that'd be the bigger one because these electrons are being pushed out by all the inside electrons. So that'd be D. Okay, now look at this picture. Where are the largest atoms on the periodic table? Remember, they get larger as you go left, and they get bigger as you go down, so the largest ones would be on the lower left. This one, you may want to refer to the picture. These are all in the same row. So within this, as you go left to right, they get smaller. So A would be, lithium would be the biggest one because it's furthest left. The smallest one here, now we're going up and down, so they get bigger as you go down. So the smallest one would be lithium of these. Which is the most reactive. Metals react, these are all metals. So metals react by losing electrons. They always have positive charges. So the bigger ones are going to react more. This, if you remember, that cesium is the one that broke the glass dish in that video that I showed you about the active metals. Non-metals react by gaining electrons. So would that be a big atom or a small atom that would gain easier? So your answer is fluorine, because it's the smallest. All right, this we've been working on lately is writing chemical formulas. Since that's +2, -2, it's CuS. K is +1. P is -3. So you need to have 3 +1s to match the -3 charge. Chromium 2 means chromium with a +2 charge. All right, there's a 2 up there. And phosphorus is P. Phosphide means P, has a -3 charge. So now you got to find a number that can be divided by both 2 and 3. Because I can't multiply 2 by anything to get 3, and I can't multiply 3 by anything to get 2. So what I'm going to do is multiply 2 by 3 to get 6, and multiply 3 by 2 to get 6. So I end up with Cr3p2. Okay, barium is +2. Oxygen is -2. So it's just BaO. Not to be confused with BO, that'd be different. And then nickel 3 iodide, that'd be nickel with a +3, and iodine with a -1. So if that's 3 and that's 1, what do I do? Right there. Okay, tin-4 nitride. This one is kind of a high number problem. So SN is 10. Nitride is in. Nitrogen's -3. -3. This is +4. So I can't multiply 4 by anything to get 3, and I can't multiply 3 by anything to get 4. So what I'm going to do is find a common multiple of 3 and 4, which is 12, the smallest one. So I multiply 4 by 3 to get 12. Whoops. Okay, multiply that by 3. And then multiply 3 by 4. So it's SN3 N4. Iron 2 hydroxide. This note means reminding you that that's a polyatomic ion. So Fe. Fe is +2. Hydroxide is OH, but OH is a polyatomic ion with a -1 charge. It's down at the bottom of your list, on your bottom of your page on your periodic table. So you're going to put parentheses here. Remember, you got to have, anytime you have more than one of the polyatomic ions, you got to use parentheses. And you put a 2 down there. Lithium sulfide. Lithium is +1. Sulfur is -2. So you're going to need 2 of these. Potassium, K. Phosphate. That ATE ending means it's at the bottom of the periodic table on the polyatomic ion list. Be sure you don't get hydrogen phosphate or dihydrogen phosphate. Oops. All right, so the K is +1, and PO4 is -3. So if that's 1 and that's 3, you're going to have 3 of these atoms to match that phosphate charge. You do not need parentheses here because you only have 1 of the phosphate ions. And then copper 2 acetate, Cu, that's +2. Obviously, I'm not putting the charges in every time, so you don't need the charges in the actual formula, but you always have to think about the charges, which is why we usually write them down, but I'm not doing it here because it's difficult the way I'm writing. All right, that's -1. So if that's 1 and that's 2, I'm going to need 2 of these. But this is one of those groups. So you get polyatomic ions, so you got to use parentheses. And put a 2. All right, so this is more of the same in terms of writing formulas. That's zinc. And this is aluminum chloride, so you have a plus sign. Aluminum chloride is Al. Now I'm going to write the formulas without explaining them this time because I just explained how to do that, and I think you know formulas pretty well by now. Yield is an arrow. And ZnCl2. Okay, so there's our equation. Then the formulas are all right. So there were 3 steps. You might want to write these 3 steps down. So the first thing you do is write your symbols down. So I'm going to put an S there for symbols. The next thing you do is get your formulas right. When you're doing formulas, you have to consider charge and subscripts. And then the third thing you do is balance. And when you balance them, you've got to use the coefficients. Coefficients are the big numbers in front. So CO is short for coefficient. Well, maybe I can write the whole thing. Co-F. Pretend I made those F's right. That's an ENT. All right, coefficient. So you got 3 chlorines. You got 2 chlorines. See how they're not equal? So what do? You use a coefficient. So you put a, shoot, I'm getting my hand on the right side of the mouse. All right, so put a 3 in here, and then you're going to have to put a 2 in over here. So that 2 times 3 is 6, and 3 times 2 is 6. since the number has to go in front of the whole formula, this 2 also multiplies the aluminum. So there are 2 aluminum atoms now where there were just 1. 2 aluminums, 6 chlorines. So I can put a 2 over here. And that gives me 2 aluminums, and we're even. So now we have 3 zinc chlorides. So we're going to put a 3 here, like that. All right, the next one, aluminum nitrate. So a formula. Having to concentrate while I do this. Okay, sodium, aluminum is +3, nitrate's -1, so it's NO3 parentheses 3. This one I did in class to review with you. So maybe 9th hour, I'm not sure if I did that yesterday. And that's sodium nitrate, NO3, plus aluminum hydroxide. Okay, so the formulas are there because +3 minus 1 multiplied by 3. +1 minus 1, you're good. +1 minus 1, you're good. +3 minus 1, you have to multiply by 3, and you have to have parentheses because it's a polyatomic ion. So now looking at the formulas, we've got 1 atom of aluminum and 1 atom of aluminum, so that's okay. We have 3 NO3 groups. Over here, how many NO3 groups do we have? Only 1. If you were thinking there were 3 groups, you got to remember that that 3 is part of the group. So here you have 3 NO3s. Over here you only have 1 NO3. So you have to put a 3 in front to make them even. And that affects the sodium also. So now we have 3 atoms of sodium which we have to deal with. So we go over here and we put in a 3, and that gives us our 3 atoms of sodium on that side. So we're happy. Except that that deals with the OHs, or that affects the OHs too. It makes 3 OHs. But if you go back over here, you'll see that you have 3 OHs, and so now everything's even, and we're not breaking the law of conservation of matter anymore. Okay, now we look at aluminum, that's Al. By the way, would aluminum have a charge in this case? No, because it's by itself. Remember, charges come when atoms combine to make compounds. So remember the 3 steps I told you to use, symbols, which I'm doing first. And then this is a little simpler, so I'll slow it down a little bit on it. So there's my symbols. Okay, formulas, that's 0, so just leave it as a standalone. This is also 0 charge, but iodine is on the list of elements that occur in pairs when they're by themselves. So you'll have to put a 2 there. And anytime, I'm not going to write these all down, but remember I told you to remember Brinkelhoff. And if you put them, I would put that on my cheat sheet, or if you remind me, I'll even tell you on the final day. Those elements that occur in pair are the bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Okay, here aluminum's +3, iodine's -1, so I'm going to need a 3 down here to make the formula correct. Now the third step is to use the coefficients to balance. So there is 1 atom of aluminum and 1 atom of aluminum, but you can see immediately that the iodines are not equal. So a common multiple of 2 and 3 would be what? I'll multiply the iodine by 3, and I'd multiply this by 2 to get 6. That gives us 2 atoms of aluminum because the 2 affects the aluminum. So over here, I just go back and adjust that, and poof, I'm done. All right, last question. You got calcium nitrate. So calcium is Ca, nitrate is NO3. I'll do this in the proper sequence, or I mean, it doesn't have to be done exactly like this, but if you think of it as symbols, formulas, and balance, it kind of helps you organize your thoughts. PO4, those are the symbols. That's a 4. All right, yield is an arrow. Sodium nitrate would be Na, NO3, plus calcium phosphate, Ca and PO4. Okay, those are symbols. Formulas, that's 2 and that's 1. So I'm going to have to put a parentheses and a 2. That's 1 and that's 3. So I've got to put 3 of these 1s to match that. Redo that. So now put a 3 right here. All right, so this is 1 and that's 1, so that's good. This is 2 and that's 3. So I need a common multiple of 2 and 3, which would be 6. So I'm going to put a, oops. Good grief. All right, so this had to be a 2. This was a 3. And this is nothing. And then this was a 3. I don't know why I keep doing that. Okay, so put a 3 here. Then this has to be in parentheses because I'm going to need 2 of this group. And put a 2 out there. All right, so now I think I have everything that's supposed to be in there for the formulas. So now the last step is to balance it. So step 1, symbols. Step 2, formulas. Step 3, balance. So if you look at this, you can see there are 2 NO3s and only 1 NO3. So you're tempted to put a 2 over here. So let's go ahead and do that. We're going to have to change it though. I'll show you what happens. So when you do that, that makes 2 NAs. So you look over here and there are 3 NAs. So now you got a problem because you can't adjust it unless you go higher. So what is a common multiple of 2 and 3? So you see if you put a 6 Na right here, that gives us 6 sodiums and 6 NO3s. On this side there are 2 NO3s, so what can I multiply that by to get 6? And here there are 3 NAs, so what can I multiply that by to get 6? So that has an effect of giving us 2 or 6 NAs, but also 2 of these PO4 groups. See, there's a PO4 right there, but there's a 2 in front, so now there are 2 of them. But if you look over here, there are 2 PO4s. And I didn't mention that when I put the 3 in front of the calcium nitrate, that to get the 6 nitrates, the 6 NO3 groups, that also made 3 calciums. But that was okay because there were 3 calciums over here. So that's how to do this practice final with a little explanation. So remember, symbols, formulas, and balance using coefficients.